it's hard to describe how honored I am to be here today. And I recognize that quite a few in the audience won't know me, won't know who I am, and I'm going to try and fill in that gap. It is truly an honor. I've counted myself as a proud member of the chemical engineering community from the day I walked into university in 1976. And to be invited to serve and the honor of president of this institution is really quite an honor. So today, what I thought we'd do is firstly talk about me. I'm not going to talk for too long. Fill in some of the gaps so you can get to know who I am, what I've done, and hopefully what drives me. I've had probably a different journey through chemical engineering than a lot of people, but every person's journey through chemical engineering is personal. So part one is Scapa Flow to the world, and you probably wonder why I've got Grant Scotch whiskey on there, the Orkneys, a robot truck, and a power station. All will be explained. So my beginnings, if anybody's listening and has got an ear, yes, there is Yorkshire in there. I was born in Doncaster and spent most of my early years around Rotherham and Sheffield, and some of the early experiences were in that industrial landscape. So they were my beginnings. There's also a little bit of a twang in there, which is American. I spent a chunk of my time living in California, but working around the globe, and I'm domiciled now in Brisbane in Australia. So I'm sorry, you may get really some screwy accent stuff going on here. I can almost remember the day. And Professor Wilkinson's down there, and he ran the School of Chemical Engineering at Bradford, and I can remember the day when I chose to go to this school, and it was in Flotter in the Orkneys. I was really lucky. I'd got a job before I picked my degree, and I was working as a mechanic, just a labourer, on the Occidental construction facility. And as was my wont in this wonderful place, when it wasn't raining and the wind wasn't blowing, which wasn't there very often, I sat with some very interesting engineers. And there's a clue in there: we are interesting. We are interesting people, and we can shape young people, and that's part of our duty in life, to bring new people into this great profession. And there were Bechtel engineers, and we were building this facility. And the ripping yarns that they told was interesting, but one chemical engineer took me under his wing and showed me a P&I diagram, explained the degasification process. So it's bring in the raw crude, stabilize it, ship out LPG, and stabilize crude. And what a magnificent thing it was. Big, stable, lots of energies, providing a product that people wanted to buy. And from there, that was the journey. So I went back. I actually applied to the University of Bradford. And I studied chemical engineering and management economics when we actually offered what I thought was a fantastic structure, which is called a thin sandwich course. So I couldn't afford a ton of money to go through university, and I did a thin sandwich course, and that allowed me to get experience in Port Sunlight. It allowed me to get experience in SO research, Fawley, where we were doing the assays on the early North Sea crudes, and blessed, I did 2 6-month periods, yes, on William Grant Scotch whiskey as a chemical engineer. That is as good as it gets. It really was as good as it got. So study, work, and learning transitioned me through to really something, and I like that T-shirt. I'm going to get a copy of it. I went through a really difficult track. See, I haven't changed that much. And I bet I challenge anybody here to go back and find their Students' Union card. I came out, joined a chemical company, did plastics, hydrofluoric acid, the fluid of the devil, as it was called in the business. But we made a lot of money out of that. And over that period, through an M&A, moved into the mining business, did mining engineering work effectively, mining process work, business work, got to set up a global supply chain and procurement system, and then found myself on the last 10 years of my career, last 10, 12 years of my career, back into hard engineering and research and development. I was very fortunate in being able to run our research and development, they called it the Innovation Group, and $100 million a year portfolio, which we brought in the universities. So I'm very proud. We dealt with a whole ton of universities, London, Imperial College in London, Nottingham, Sydney, Brisbane, University of Queensland, MIT, Tsinghua in China, and Laurentian in Canada. And we graduated a ton of chemical engineers out of that program. It was really cool doing flotation with Jan Sillers and his group in Imperial College, and high energy physics, looking at how mineral species change when you bombard them with very high energy microwaves with Sam Kingsman's group in Nottingham. So it is a journey. It's a life journey. I moved through this system and came back to engineering and loved every minute of it. So, okay, what are we going to do with that? And what am I planning to do with this platform in assisting this great institution as we go forward? And that's what I want to try and explain to you. We're going to go through a part here now, which is, hopefully it is intriguing. It's called the governance of the organization, but it's why we do it, to open up opportunities and support our strategy. And then I'm going to go into a world that I'm very familiar with, which is the world of exponential and exponential digital, and how that can apply to massive process industries, which I've done, robotics, which I've done, big data, which I've done, predictive analytics, which I've done, and cognitive computing, which I've done, because it's coming to a profession near us, and it's coming to our profession. So first of all, let's go through the institution. Almost half the IChemE membership is linked to a cyclical industry. This was the industry that looked like the major opportunity that I was going to have when I graduated, but I ended up going through a chemical company. And that's something connected with petroleum and the chemical derivatives of petroleum and the wider chemical industry. And we do get hit with the cycles. I'm very familiar with cycles, being in the mineral and extractive business for a long time. We knew that they were coming, and we managed our way through them. That's not great if you're a new graduate coming down at the bottom end of a cycle. And as we've seen, we do have those cyclical effects. These are industries that are deep in our DNA. To a large extent, chemicals and petrochemicals form this fantastic institution, and we have symbiotically moved forward together, and we're going to evolve and grow into these industries. But look at what's happening around us. And Jonathan Seville made this point last year. He also made the point that there are the other industries that are growing up around us. And this is just somewhat of a pictorial. We are everywhere. We move into places. Look at the biotechnology, where when I moved into university, it was just a gleam. Genetic re-engineering, the production of fuels from genetically modified crops. Front-end, fast-moving consumer goods, batteries, energy and energy storage. I'm into that world at the moment, and anybody who cracks that is going to really do good for the planet. And we're in the middle of these big fluidic batteries. We're also in the middle of the production of the other battery systems. So it's just opportunities. We're not turning our back, and we can't from our traditional roots, but we can grow, and we're going to be able to grow into these areas. And that's where the growth will come from, I believe. And going back to this great piece of work, because chemical engineering does matter, it's good as a reference document to go back to the work that we do in energy, the work that we're doing in food and nutrition, health and well-being, and water. We do impact the quality of life. And this quality of life is really important to the people that are out there, to the societies that we're in, and we can, with our members, make a big impact here. I've always looked at the world as opportunities. Every time a problem comes my way, it's an opportunity. And wicked problems need very smart people to solve them. And these are pretty wicked problems in a population that's heading towards 9 billion, in an energy system that's switching to a low-carbon system, food and nutrition that we need to feed with protein, and the water deficit around the world. This is a great time for us. This is a great time for our people. It's a great time for our institution and all the stakeholders around us as we move into these basically society-wide challenges. I'm just going to let this flow. Just look at the faces of the people that we employ. And this is just a little smorgasbord, and some of the medal winners from the various jurisdictions. So we have a reach, we are global, and it is an institution that is attracting people. As we see, we've ridden through the global financial crisis, and we're on trend line with the rest of the graduate intake, and we're on a good trend line for employment. I want to point this individual out. It's from a document in 2011, and I'd like you to think profoundly about this. I'd like you to think about our generation, and looking around the room, and these people, because they are different. They are different. This is Generation C, Generation Connected. If you were born after 1990, you don't know what it looked like before then. You are connected. Paper is an anathema. They communicate. There's a Venus and Mars thing going on. A female in the upper quartile of the advanced economies will send and receive about 300 SMSs a day. That is the communication vehicle. The male does about 200. How are we going to bring these people in to power our institution? How are we going to bring these people in and support the educational establishment and also the employers if we remain in a place that they don't recognize? The technologies that these people are looking for are technologies that are just coming at us. And we have to recognize that as an institution and be ready to have the conversation. And I think there's some great opportunities there. I encourage you, that's a Booz Allen Hamilton report of 2011. I've read a ton of this stuff. I've employed a ton of those type of people. It's the most succinct 2 or 3 pages that describes the society that's coming at us. So when we talk about governance, we're going to move into governance, and then we're going to get to the technology, the digital stuff. Imagine it as a Rubik's Cube. We've got a lot that we have to do with this institution. We've got to meet the graduate expectations. Look at that global footprint. Was it in over 100 countries? And we got there. Delighting the employers. What is their aspirations for the use of a vehicle like IChemE and our learned society in navigating their people through? And I won't read the rest of it. We have a lot of tension around the organization pulling on us, but that's a wicked problem that we can solve. And the point that I will be talking about later, we have things that are happening outside the institution called the exponential world that will reshape us and will reshape the profession and will reshape the expectations, and we have to get in front of it. However, governance. I've done a lot of this stuff in my life. I've done governance reviews and governance implementations of pretty big systems. So we've looked at the strategy. We've refreshed the strategy. You've got a strategy, structure, tactics, plans, action, measures, and governance surrounds it. It's not something that you do on the side. It's something that is all-encompassing. And what is the governance approach that we need for an institution like ours as a 21st century professional engineering institution? That was the job that I put my hand up for a year ago. We started to look at this a year ago. How we can connect the institution, how we can govern ourselves, how we can get closer to the members. And it's a piece of ongoing work, and the commitment that we've given, I'm looking at the CEO, is we'll finish it, we'll complete it, and we'll get through the work, and we'll bring that back here this time next year. I just want to know some of my style. I had the opportunity to chair the Australian Learned Academies. I'm a member of the Technology, Science and Engineering Academy. I chaired the review into the PhD system in Australia. And it was successful. 11 of our recommendations, which were 13, have been implemented. Why was it successful? It was consultation. 90 face-to-face meetings, 12 public forums, consultation, listening, bringing information in. Everybody has a right to make their opinion known. Some of it won't get through, some of it will, but we need a heavy level of opinion because the governance approach for the 21st century institution could reshape us. Not going to labour it. The Canadians actually managed to simplify this stuff better than anybody else. There's only 4 rules there. And look at it, when anybody's giving you a governance pack, ask the question, who's got the power? Who makes the decisions? How other players make their voice heard? And how is account rendered? And that gives you the checks and balance in that system. So, it's a complex construct. Part of the work that I want to do while I'm here in the next year is to work with management, with the membership, with all of our members, and we work our way through this and we get the right governance for a 21st century institution because the world is changing around us. This is not going to be a technology presentation, or it may seem it, because I'm going to join the dots right at the end and make it very chemical engineering. I've called it thriving in an exponential world. It's happening. Exponentiality, the pace of what is happening with these machines around us and how it is influencing the way that professions work, and also the careers that we're going to have in the future and the way that we're going to shape, is staggering. I actually do remember the slide rule. I do, and I remember log tables, and I never managed to get punch cards to work. I just threw that lot away, and I got myself a HP calculator. And now we have we've gone through Generation C, I only know the tablet or the equivalent. And sitting there in the cloud, there's a hyper powerful cognitive learning systems that are starting to do the work of the professional. And we need to manage them. We can't be dictated by them. So I'm going to take you through some of the pace of change, and then I'm going to show an example at the end. I couldn't afford to run a car all the way through university. I had a Honda 175 and I had a top box, and the top box was full of a copy of Perry's. And I've actually found the copy of Perry's from 1976, and it's a big tome, and I lived with that tome for the early part of my career. And it's gone mobile. It's gone to an e-book, which is kind of a big tick, so you don't have to carry this thing around. It'll be on your mobile phone. We need that. I suspect everybody or most people here have enjoyed the intellectual challenges of heat balance, a mass balance, or some kind of wicked thermodynamic challenge. And we have the reference sources of all the smart people that put this stuff together. That's great. But the world's changing. Perry's in its current form, which was updated in 2007, is already out of date. What is the new knowledge that's been published since Perry's was last updated? It will be orders of magnitude more than the knowledge that's in that book. And it's locked off. We can't see it yet, but it's coming. So, a couple of things. Let's go to cognitive computing, and that is thinking machines, thinking with a small t, not a big T. Machines that are able to look at context, that are self-learning, that can derive from masses of data. Remember all the Bernoulli's equations and those beautiful equations that we know? The machines will find the relationships, and they don't even have to know about the equations. So IBM Watson, it won Jeopardy in 2011. That's quite a way back. 2 terabytes of data, so that's 200 million pages of data in all of Wikipedia, and it beat the Jeopardy game show players. That's okay. The more free form, because it's a game of tactics, it's a game of strategy, is poker. And Libertas won a world championship in poker, and the machine earned itself, I think it was $1.5 million in Pennsylvania. These things are starting to think. They're coming at us. So, what's it happening in other professions? And I can't put the chemical engineer in there. So in typical general practice, and think about all the engineers, think about all the stuff we'd have to read. A GP, I read a book that said a GP reading the publications that they really should read, should be reading about 160 hours a month. Impossible. Absolutely impossible. The same with legal. There's a cognitive platform now that supports general practitioners. The machines are doing that reading, but they're not only doing that reading, they have the total entrapped knowledge of all the medical science ever produced. So would you want to see a GP with one human lifetime of experience poking around at you? Or do you want to see the GP with a human lifetime of experience supported by a cognitive agent with the experience of everybody? This is going to come to us. Unstoppable. Same has happened in law. In fact, my daughter is in law. She's going to do the law, but her total focus is not to do the law in the way that people used to do the law. She's being paid by law firms to go and disrupt the legal process by using the machines. So what's shaping this? Just to give you a little bit of the background, yes, we did some very hard chemical engineering. We really pushed back the frontiers of science in flotation, in plant controls, in complex systems, and in microwave technology as it moves into minerals, but we did an awful lot in data. And it was these big four drivers that were driving us. So those four drivers allowed, in my last role, the first fleet of fully autonomous vehicles. We talk about Tesla wanting to do it, we did that. Military technology, it is now possible to read a plant. This is a mineral plant, not a chemical plant, with 250,000 sensors, real time, from the other side of the world, have the machines looking at the patterns, embed inside those processes. There's only 6 key processes, effectively the PhD knowledge, and then put in really smart people, really smart engineers, and get process control to a level that you could never get with our current process control systems. So, independent thinking and learning. Every time the plant goes on an excursion, the machine learns the excursion. If it ever sees it again, it starts telling humans and say, this is how we stop it. So these are the exponential forces. You all know them, and I'll be touching them in a minute. So it's the chip, it's the storage capacity, it's the connectivity, it's the sensors, and it's the science, and it's the data science that's coming out of 3 particular fields. Genomics, astrophysics, and also the astronomy, the big square arrays, how to manage these data fields and look for the patterns. Cost. We employ people, they go up. This is what's happened. I'm sorry I couldn't get any more data after 2012. But just look at the cost power changes. Data storage is trending towards zero. It's trending towards zero. So I think in the next 15 years, and I do advise very senior people, I'm going to advise the institution, we're going to have a microchip that costs less than $1,000 with the same number of neurons as us. The data storage capacity is going to continue. There's no sign of that exponentiality slowing down. These will have gone down by an order of magnitude since 2012. And this knowledge, think of the knowledge we have in all the textbooks that we've published. Think of the knowledge we've got in Perry. Think of the knowledge that we're producing every single day. That is moving into the corpus. It is moving into the machines. And it's how we use that and how we become the masters of those machines that Generation C want to know about, because Generation C are going to be the people occupying these seats in this place in years to come. And we can't afford to lose them, because if we lose them, we have no new members. There's another one there. Cost versus performance. It's just staggering. There's another one here that makes me laugh. Terabyte used to be big. We throw around petabytes because you need to do that. It's just a big number. Remember the 3.5-inch disks? Storing a petabyte in an old 3.5. We will move petabytes a day through the cloud absolutely with ease and do the analysis on the fly, applying known rules or getting the machines to find the rules. So the old storage of a petabyte, I love the one at the bottom, which is the old 3.5-inch disks, which I grew up with. If you stored a petabyte on them, they'd weigh about as much as 2 Type 45 destroyers. It's now common. So how does this all work with Perry's? This is the hypothesis. When you look through Perry's, you've got the sum wisdom of all the people that came before. You've got the output of all those PhDs. You've got a corpus of knowledge that, as we know, stopped now in 2007, which is the last time it was updated, but the knowledge doesn't stop. Our universities keep publishing that knowledge. It will go cognitive. Absolutely unstoppable. It's only a question of time, because those nice people in Silicon Valley only look at value, and it'll be value over time. It can be done today. It just depends on how much money we want to spend at it. And if it's too expensive today, just wait a year. It'll be half as much. What does our industry look like when these things come online? What do we look like as engineers when these things are online? Well, my hypothesis is it's a good place to be. Because we're chemical engineers, we have the wisdom, we have the profession. We've got 44,000 people behind us, and we just have new tools. Doesn't mean we're replaced. What can we do when the thing on your iPhone is the sum knowledge of everything we ever knew about thermodynamics, or everything we knew about plant design? And you can talk to it, and you can interact with it, because we have wicked problems to sort out, and they're the energy, the food and nutrition, health and well-being, and water. Just go back and look at chemical engineering matters. We've got a lot of work to do, and we can do it as a profession. That Generation C is going to come through, and these tools are going to change us. We can't stand in front of it, because just look what's happening to the doctors. So it really matters. I'm not going to go through the full detail. You know this document better than I do. The amount of work that we have out there. There's never enough people. Bring some knowledge into the corpus, release the people, and we can start working on some very important aspects of life. So we'll starting to close out now. I do actually have a example for you. I'm sure there's lots in the audience saying, well, that's good, I've heard that before, but maybe not in my lifetime. Well, that's not the case. So what about jobs? Just a touch about jobs. We've been through industrial revolutions and seismic changes as society for a long time. I'm an economist as well, and I kind of get off on that stuff. If you're standing in 1920, and somebody said, well, employment, we've got 100 million people in 1920, and where we are today, it's 36 million, 360 million, 340 million. And how are you going to put them all to work? Woe is me. If you're standing in 1920 and you say, well, I'm sorry, by the time you get to 2017, the agriculture and related jobs are effectively gone. They're actually being run by machines. That the manufacturing and blue collar has shrunk. Right? That's probably what we're seeing. There are eminent scientists, and there's great reports out there saying there'll be a seismic shift as the cognitive systems come online. But we can't tell what the world's going to be. We just know it's going to be different. And standing in 1920, looking at the US now, which is approaching technical full employment, she's 4.7% unemployment, but the population has tripled. Some technologies have come in, industries have gone, but other industries have opened up. So, I hope I painted that picture. And I'm going to try and give you an illustration. This is a piece of work Andrew Jameson used to be involved with Woodside. I've followed this for years, and we're running some little work on this, which is not the knowledge in chemical engineering, but it's actually the knowledge in massive fluid dynamics, which is a hydro system that I'm involved in at the moment. So look at the title. What do we look like when every person that's qualified thinks like 1,000 engineers? Let's just run this video. Can we drop the lights so we can see the video, please?
I know you, friend. I know every meter, every gap, every specification. I know every metric unit of pressure imposed on your 119,000 tonne frame and how it will react to the extreme conditions here on the remote northwest shelf. I know what a team of engineers in Norway reported on you and what a retired project manager documented on you a decade ago. I know fuel mixtures and flow rates, hard data and soft data. I know all this because we're designing a cognitive system with IBM Watson that consumes and learns everything written or reported about you from millions of files, decision logs, and technical evaluations spread across our company. We teach Watson to think like an engineer. Watson teaches us to think like 1,000 engineers from 1,000 different sources. I know temperatures and pressure gradients, anomalies and patterns. When you succeed, I will know why. I will know how. With Watson, we're asking more questions because we have more answers. We're making smarter decisions because we learn more every time we make one. And I know we're just getting started.
And if it's too expensive today, wait a year. And if it's too expensive in a year's time, just wait another year. Coming to an iPad near you soon. That's what's going to happen. So, just some closing observations for you. This is a fantastic place to be. We connect. We don't have a narrow, deep, restrictive concept of what a chemical engineer is. We're in all industries. We have the sunshine industry coming at us. We have to be receptive to Generation C. We've got a strategy in place. We're global. We have to get our governance right. We have to engage with the membership deeply. And we've got this stuff that's it is impossible to stop. But what a fantastic opportunity. And wouldn't we all have liked that when we were studying? So it's a good time to be thinking about this. It's a multi-dimensional problem. It's something that we want to get in front of. In the time I'm here, the only thing I can say to you, these fantastic members, is I'll do my best. I will champion the governance work through because I really mean it, and I've done a lot of that. I'll try and raise the debate here. This is too big a debate. It's a profound debate. All our members need to think about this, and it will take us into different directions. And quite how those directions pan out, we don't know yet. But it is coming. So, thank you very much. Look forward to the wicked problems because the amazing tools are coming. And I think that's the end of the presidential address.